To another math lesson with Math Magic with Jen. Today we're going to add fractions. It's my second adding fractions video, but this time we're going to use area models rather than tape diagrams. Oops. So let's check it out. Okay. So with the tape diagram video, and hopefully you've watched it, the idea behind it is that one of the two fraction denominators is the common denominator. So, for example, one of the problems was 1/4 plus an 8. So we can build the 4 into an 8. Okay. So again, that's a previous video. The idea though here is that if I wanted to add a third plus a half, we cannot build a third into a half and a half into a third. We need to have a different common denominator. We're going to have a common denominator of 6. Okay. So what I want to show you is we're going to show this method using an area model. And how it works is that an area model is a square, or what I kind of like to call a fat rectangle. It needs to be wide enough so that you can slice it in two directions. So I need to be able to slice it vertically and horizontally. Okay. So typically what we do is our first cut is up and down. So you can see from this lovely area model, this lovely area model, we've sliced it into 4 and shaded 1 out of the 4. How an area model works is that we're now going to slice it in the opposite direction. So I can cut it into 2 rows, 3 rows, 4 rows, you name it. So over here, if I cut it into 2 rows, you're going to see that this original is 2 out of a total of 8. If I went over to this one and instead cut it into 3 rows, we'll pretend they're equal rows, this would be the same thing as 3 squares out of 12. So it's a really nice way to make equivalent fractions. You're just basically slicing in one direction and then another. Okay, so how are we going to use this for adding fractions? So how this works for adding fractions is that we're going to make 2 area models, each one representing each fraction. So I need an area model for 1/2, and I need an area model for 1/3. Now, it doesn't matter which one I write first, draw first, a half or a third, because addition is commutative, but we'll probably just get in the zone or the habit of the first fraction will be the first area model and the second fraction will be the second area model. Now, if you notice, these area models are cut in different directions, and that's the trick. So you want to cut one vertically and the other horizontally. Okay, so I'm going to cut this one up and down, and I'm going to shade 1, 2, so that's representing a half. And then the second area model, I'm going to cut a cross, and here I've represented 1/3. Now you may be wondering why we shaded the bottom instead of the top. You can shade either. As long as you're shading one of those 3 pieces, it doesn't matter, but you have to shade one. So any one of those 3 will work, just like any one of these 2 will work. Okay, so right now we have 2 area models, one representing each fraction, one cut up and down, one cut across. Okay, here's where the magic happens. We're going to cut to match. What that means is we're going to cut the first one across 3 times to match this one. And the second fraction, we're going to cut up and down twice. So I'm going to cut this one into 3. 1, 2, 3. And I'm going to cut this one up and down. Okay. The magic here is we now have a common denominator just by cutting the match. Okay. What you want to do is count the fractions. Cut the shaded region to create the fraction. So this first one is 1, 2, 3 out of 6. The second one is 1, 2 out of 6. So we just got our common denominator, 3, 6 plus 2, 6. And of course, our picture is just to get the common denominator. After that, our students can just add. So 3, 6 plus 2, 6, we just add straight across and we get our 5, 6. And that is the magic of area models. I love it. I think it's very clean and cool. It's a very nice visual process of what's going on. Okay, now you're probably wondering what about the standard algorithm? I'll show how it connects in just a second, but let's try another one, okay? So here I've got 2/3 plus a fourth. Okay, so first thing that we're gonna do is we're gonna represent 2/3 with this first area model. So I'm gonna cut it into 3. And I'm just gonna lightly shade 2 of the 3. Beautiful. So that's my 2/3. And then this one, I need to cut the other direction. So we're gonna cut this across and I need to cut it into fourths. They're supposed to be equal, but I will say area models are a little bit more forgiving for the equal part. Okay. And now I want to shade any one out of the 4. So you could do the top, you could do the bottom, whichever one. I think I'm gonna go with the top. Beautiful. Okay, now what we're gonna do is we're gonna cut to match. Now, I would love to use a different color, but maybe your students are just using a pencil and only a pencil. So here's what we're gonna do. We're gonna come over here and we're gonna kind of overcut so that that way they can see their slices. So here I'm gonna slice 1, 2, 3, and 4. So again, I'm kind of purposely going over so they can see their cuts. Okay, so here I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 out of a total of 12. Okay, and we're gonna do the same thing over here. Remember, I cut up and down in thirds. So we're gonna do that again. I'm gonna kind of go extreme, going overboard so that we can really see those cuts. And then you'll notice that our 1/4, which I neglected to write earlier, 1/4, is the same thing as 1, 2, 3 out of 12. Beautiful. 8/12 plus 3/12. That's the same thing as 11/12. Nice, right? Okay. All right, let's do another one. What if I want to do 1/3 plus 2/5? Okay, so we're gonna go ahead and cut this one up and down to represent 1/3. Just lightly shade 1 out of the 3. And then over here, we need to cut this one across into 5. Do you like that scrunched up face I made? How am I gonna make this look like 5? Carefully, very carefully. Okay, we're gonna shade 2 out of the 5. Now, you don't have to shade 2 in a row, so technically you could get creative and do any 2 out of the 5. I don't know why you'd want to, but let's pretend we decide to do that. Okay. All right, so these 2 are the 2/5. Okay. Now we're gonna cut to match, and I'm gonna overcut to really show what I'm doing here. So 1, 2, 3, 4, and 5. And this looks like it's 1, 2, 3, 4, 5 out of a total of 15. Okay. And then over here, we're going to overcut again in thirds. And I have 1, 2, 3, 4, 5, 6 out of 15. Okay, now, students that have had a lot of practice reducing fractions, a lot of times will try to reduce the 5/15 back to a third or 6/15 back into a 2/5. Resist that urge. We went through all this work so that I had the same denominator. So I want the same denominator so that I can glue them together. Gotta have it. Okay, so we want that 11/15. Want it, want it, want it. Okay. Way, this could easily be subtraction. For this problem, it would be 2/5 minus a 1/3. And we would honestly do this problem the same way. We would just end up getting 6/15 and 5/15, but how we glue them together is just the only part that's different. So this method, even though I've been doing addition, this method can be used for subtraction. All you've got to do is just, it's how you glue them together in the end. Oh, what about the standard algorithm? Okay, so if you think about it, this 1/3 we cut into 5. Cut into 5 to match. So what we're really doing is taking that 1/3 and multiplying by 5/5. And this area model over here, we cut into 3 to match. So that would be the same thing as multiplying the top and bottom by 3. So we are working towards that standard algorithm. We're just doing it in a visual kind of fun way. Okay. All right, and as I already mentioned, we can use this method for subtraction. Let's go ahead and do one more just to practice. So here, if I had a half minus 1/5, I'm gonna have, let's see, we'll cut it up and down to represent a half. We'll cut this one into fifths. Wow. And this time I'm gonna shade the bottom one. What the heck? Jazz it up. Okay. I'm gonna cut to match, but I'm gonna go over the side to make it really obvious where I'm cutting. And then when I count, I'm gonna get 1, 2, 3, 4, 5 out of 10. And this one, I only have to cut once into 2 halves. So here, this would be the same thing as 1/5 is the same thing as 2/10. Okay, great. So here, because it's subtraction, we want to make sure we're doing 5/10 minus 2/10. And yes, I get the final answer of 3/10. All right. I hope you enjoyed this video. I hope maybe you learned something new. I don't know. I will say I know that a lot of people have math baggage about fractions, but I'm hoping that these videos are helping make it a little better. So just do your best, try your hardest, and keep inspiring those students and getting them to work hard. Until next time, have a wonderful time doing math and learning together. Have a good day. Bye-bye.